Hi, Assalamualaikum. Before I start the presentation, I would like to introduce a bit about myself. My name is Ahmad Faiz bin Babar. My matric number is CN180047, and I'm from the program of BNL, which is Bachelor of Mechanical Engineering Plant. My supervisor is Dr. Nawaf Zaniza bin Samiran. In this Bachelor Degree Project 1, my title is about the effect of impeller design in the steel tank on the performance of the missing flow characteristic. For the introduction, steel tank are among the most commonly used process equipment in the chemical and the other process industry due to their high missing capacity and the scalability. They can be classified according to the mode of operation of the units, which can be batch, semi-batch, or continuous. Many factors can be influenced missing efficiency, but one of the most important is the impeller form. The present study aims to investigate the effect of impeller design in the steel tank on the performance of missing flow characteristic using the two types of impeller, which is pitch blade and the pitch blade 5. For the problem statement, for the current impeller design, in the previous study, there still has the settling of the particle at the bottom of the tank. The new design of the impeller has been built to minimize the settling of the particle at the bottom of the tank. Number of blades has been added to investigate the performance in the steel tank. According to Karimi 2013, study that the number of impeller blades has a considerable impact on a missing condition. For the objective, there are two objectives that I need to achieve. The first one is to investigate the effect of number of impeller blades on the velocity counter and the velocity flow via single-phase model using the SolidWorks flow simulation. Second is to investigate the settling of the particle at the bottom of the steel tank using the SolidWorks flow simulation. For the scope, there are 6 scopes. The first one is to design of conventional pitch blade turbine impeller, which is 5 and 4 plate of impeller. Second is 4 pitch of buffer with width of 0.03 meter and the length of 0.29 meter is installed in the steel tank. Tank design is a cylindrical vessel with a flat bottom. Only batch system will apply, which is no pipeline will be involved in the steel tank. The rotational speed is from 60 rpm to 135 rpm. The Fabre average and Navier-Stokes equation are used to predict the turbulent flows. For the methodology, this is my flowchart from the start of the Psm1 until done. And for the Psm1, I only do until the assembly of the steel tank. And for the machine and the CFD flow simulation, I will do it at the Psm2. Okay, next is the geometry development. The steel tank and the impeller design is based on the previous research geometry, which is from the Russell 2017. For 3D modeling, I have used the SolidWorks software to build the impeller and the steel tank design. For the simulation, I will use the SolidWorks flow simulation. Two types of impeller is being built, which is pitch blade and the pitch blade 5. As you can see, this is the sketching of my steel tank. In the inner diameter of the steel tank is 0.3 meter. The inner height of the steel tank is 0.33 meter. The width of buffer is 0.03 meter. The buffer length is 0.29 meter. And the buffer thickness is 0.04 meter. The distance between the impeller and the bottom of the tank is 0.1 meter. The distance between the bottom of buffer and the bottom of steel tank is 0.02 meter. Okay, next is about the impeller design. The impeller, the two impeller, which is pitch blade and the pitch blade 5, has the same geometries. But the difference between the pitch blade and the pitch blade 5 is only the number of the blade. For the pitch blade, there are 4 blades, and the pitch blade 5, there are 5 blades. The diameter of the impeller is 0.1 meter. The impeller width is 0.2 meter. The impeller hub is 0.02 meter, and the angle of the blade is 45 degree. For the method that have been used, for the numerical method, I has used the Reynolds average Navier-Stokes equation for calculate the mass conservation and the conservation of the momentum. For the numerical method, I has used the Fabre average Navier-Stokes to predict the turbulent flows. Next is the boundary condition. On the outside and the bottom walls of the straight tank reactor, buffers are represented as a solid walls with no slip boundary condition, which is V equal to 0. The impeller and the agitating shaft were designed as the moving walls in the straight tank. And lastly, the expected result. For the expected result, the new design of the impeller will increase the missing performance in the straight tank compared to the previous design. The velocity contour and the velocity vector will show an ascending graph compared to the previous result. Okay, this is my Gantt chart for the PS1 from the week 1 until the week 14. Okay, that's all from me. Thank you very much.